Data structures using C, implementation of binary tree. During this lecture, we will learn how to implement a binary tree using C and implement various traversals of binary tree. That will be done during this lecture and the lecture follows. In this lecture, we will just delve with the implementation, two types of implementations of binary tree. There are two types, as I said, of implementation of binary tree. One is array implementation. Use an array. This is a non-linear data structure, but we are going to use a linear array to represent the non-linear data type. And here we have the linked list implementation, and here as you see it is non-linear. You have got the root here, and then you have got the left subtree and the right subtree. Here everything is in the form of an array. Let us see how it is done. So here you have got the array implementation. This is the tree, that is binary tree, binary search tree. As you see, this is the root, and we number this. Root is numbered as 1, then first level 1, 2, 3, then level 2, 4, 5, 6, 7, level 3. So then 8, 9, 10, 11, 12, 13, 14, 15. So this is how these nodes are numbered. Therefore, as you see here, we are using an array here. So 1, the root goes into space 1, and 20 to 2, 80 to 3, etc. So as you see, 9, 90 is here, goes to the 7th location, 8th is blank, then 9th location has 15, 10, 11 are blank, there is no leaf nodes here. Then here 12, 13, as you see, 55 and 70 are in 12 and 13. Again, the 14th space location is empty, and the 15th location has 95. So this is the array implementation of the data type, the data structure, that is tree data structure, starting from 1 to the respective locations. We use that especially in heap. We use the array implementation. Then we come to a few more points about array implementation. The complete binary tree with n nodes is represented sequentially as described before. So parent node. So suppose I want, other than the root, so what is the index of say parent node? For example, here index of this parent 50 is the parent. So therefore I here by 2, I by 2 will give me the parent here. For example, 4, this index is 4. What is the index of parent? I, that is 4 divided by 2. I get the parent of the left child. If it is the right child, what do I do? If it is the parent is given, all right. Now, how do I get the left child and the right child? So left child is got, suppose I is the index of the parent, left child is 2i again. So here this is the index of parent, left child is 2i4, and here 3 is the index of parent, 2i, that is 3 into 2 gives me the left index of the left child. How do I get the index of the right child? As you see there, it is 2i plus 1. So it is 2i4 plus 1, 5. Here 3 into 2 is 6 plus 1 is 7. So this is how we get the indices of either the parent node or the left child or the right child. So this is how we implement the data type, that is a tree data structure, using an array formulation or array. Now we come to linked list implementation. So as you see here, this is the root, node, and we have got the left subtree and the right subtree. So how do I represent each node? I use a structured data type. I create a new data type called tree node, which contains number, and it contains pointer to left and pointer to right. As you see here, pointer to left node, pointer to right node, and this again pointer to left node and right node null. So here points to right node. Similarly here points to left node and points to right node. So this is how we represent the node of tree using linked list implementation. We are going to do that. This is just to understand, for your understanding, how we represent. So this is the node number, maybe 70, maybe 93, maybe 31. There is a left link and the right link. So here's is a type def struct tree type, number is the data, then struct tree type right, pointer right and pointer left. This is a pointer. This is a pointer to the next left child and the right child. So this is how we are going to represent tree using linked list implementation. Thank you.